Hello, 6th graders. Welcome to Big Ideas Math, Section 1.5, Greatest Common Factor Lesson. Pause while you write Section 1.5 lesson in your math notebook. Pause and write today's lesson objective in your interactive student notebook. Today's objective is, I can identify the greatest common factor of two whole numbers less than or equal to 100 using various strategies by completing Big Ideas math practice with 100% accuracy in multiple attempts. Today we'll be working on pages 32 and 33 in your math textbook. Yesterday you wrote the key vocabulary in your math notebook, so you don't need to write that again today, but we will review it. Factors that are shared by two or more numbers are called common factors. The greatest of the common factors is called the greatest common factor, or the GCF. One way to find the GCF of two or more numbers is by listing factors. Example 1 is finding the GCF using lists of factors. So we're going to find the GCF of 24 and 40. We're going to list the factors of each number. So when we do that, we find the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. And the factors of 40 are 1, 2, 4, 5, 8, 10, 20, and 40. And the book has us circling the common factors. And the common factors of 24 and 40 are 1, 2, 4, and 8. Those are the ones that are circled. And the greatest of these common factors is 8, and that's the one that's circled in red. So the GCF of 24 and 40 is 8. Another way to find the GCF of two or more numbers is by using prime factors. This is really helpful when you get into larger numbers and you don't want to make factor rainbows for giant numbers. The GCF is the product of the common prime factors of the numbers. So that's an important thing to remember. This is kind of a new skill for you. So let's look at example 2. Finding the GCF using prime factorizations. Find the GCF of 12 and 56. So our first step is to make a factor tree for each number. So if we make a factor tree for 12, we start with 2 and 6. 2 is prime, so we can circle that so we remember that it's prime. 6 is not prime, so we need to keep going with 6, and we factor that out to 2 and 3. Those are both prime. And then we're going to go ahead and factor 56. 7 times 8 is 56. We know that 7 is prime. 8 is not prime. 2 times 4 is 8, so we can circle 2 because it's prime. 4 is not. 2 times 2 is 4. So the prime factorization for each number looks like this. 12's prime factorization is 2 times 2 times 3. And 56's prime factorization is 2 times 2 times 2 times 7. So then the directions are to circle the common prime factors. So they're considered common if they're in both prime factorizations. And since 2 is in both prime factorizations 2 times, we list it 2 times. So 2 times 2, and then we multiply that. 2 times 2 equals 4. So the greatest common factor of 12 and 56 is 4. Let's read our study tip off to the left. It says examples 1 and 2 show two different methods for finding the greatest common factor. After solving with one method, you can use the other method to check your answer. So this is a common question that we get with Common Core, which is why do we teach so many different methods for doing things? Multiplication, division, subtraction, addition, and now greatest common factor. And here's the answer. If you have a question, you can always check your work using a different method. So here's the answer. We like to be able to check our work, and if we check our work using the same method, we're always going to get the same answer. If we check our work using a different method, it's a good thing to know that we're right using a different way of doing it. Now let's turn the page, go to page 33, and let's look at example 3, finding two numbers with a given GCF. Which pair of numbers has a GCF of 15? So now we have to work backwards to find the numbers that have that GCF. Our choices are letter A, 10 and 15, letter B, 30 and 60, letter C, 21 and 45, and letter D, 45 and 75. So this really tests our knowledge of basic facts and knowing what a factor is. So let's think about the first statement that the book makes here. The number 15 cannot be a factor of the lesser number 10, so you can eliminate statement A. So remember that a factor multiplies by another number to get a product or a multiple. So you can't multiply 15 by another number and get 10, at least not another whole number. So letter A doesn't work. We can cross that out. The number 15 cannot be a factor of a number that does not have a 0 or 5 in the ones place. So if you think about the multiples of 15, 15 times 1 is 15, 15 times 2 is 30, 15 times 3 is 45, and so on. So everything ends in a 5 or a 0. So you can eliminate statement C because 21 doesn't work. So we're left with B and D. So it says list the factors for statements B and D, which they did for us. Choice B, factors of 30, they've listed for us. And our greatest common factor there is 30. And choice D, factors of 45, are listed here, and they've circled the common factors in blue and circled the greatest common factor in red. And the greatest common factor here is 15. So the greatest common factor of 45 and 75 is 15, and that's what we're looking for up here in the question. So the correct answer is D. Example 4 is the real-life application. So you are filling piñatas for your sister's birthday party. The list, which is over to the left, shows the gifts you are putting into the piñatas. You want identical groups of gifts in each piñata with no gifts left over. What is the greatest number of piñatas you can make? So the numbers that we're working with are 18, 24, and 42. They're right down here, and they're also on the list. The greatest common factor of the numbers of gifts represents the greatest number of identical groups of gifts you can make with no gifts left over. So to find the number of piñatas, find the greatest common factor. So what you would do is you would make factor trees for each of these numbers. The book cut to the chase, and they went ahead and gave you the prime factorization for each of these numbers. So the prime factorization for 18 is 2 times 3 times 3. You can check that by multiplying. 2 times 3 is 6, times 3 is 18. And the prime factorization for 24 is 2 times 3 times 2 times 2. And 42 is 2 times 3 times 7. So since there is a 2 in all three of these prime factorizations, see how there's a 2 in all of them, And there's an extra 2 in the 24, but it doesn't have a friend to match up with in each of the other 2. So we're not going to put that in our product that we're multiplying down at the bottom. And there's a 3 in all 3 of our numbers, of our prime factorizations. And there's a spare 3 up in 18, but it doesn't have a friend to match up with, so we can't count it. So there's a 2 in each of them, and there's a 3 in each of them. So we're going to multiply that. We find the product of the common prime factors, 2 times 3, which equals 6. So the greatest common factor of 18, 24, and 42 is 6. So you can make at most 6 piñatas. Remember, if you have questions about any of these examples, mark them in your math notebook, write down what you have questions about, and be sure you ask me in class and write it on your exit slip. Remember, to earn credit for viewing your flipped lesson, you need to complete your notes in your interactive student notebook, complete your on-your-own questions in your interactive student notebook and in your Google form, and complete your Big Ideas math assignment in your math notebook and submit that when it is 100% correct. Remember to visit your teacher if you have any questions.